Hi, welcome to my talk about speed versus risk today. My name is Julian Totzek-Hallhuber, and I'm Solutions Architect here at Veracode. At Veracode, we do application security testing. But let's jump right in here and talk about this in more detail. Why do we actually need to talk about speed versus risk when it comes to application security testing? Well, most people believe you cannot reduce risk at speed. This is maybe because of the fact most organizations moving their development into agile, DevOps, or even DevSecOps. With, let's say, legacy development methods and monolithic applications, scan times were pretty long. The perception always was security scanning taking time, which still is very true, specifically if we talk about manual penetration testing. However, there are modern ways of scanning applications that will perfectly fit your development processes. You will be able to scan even at the commit stage and tell a single developer what is a finding on that single commit. Let's start talking about the three main different scanning technologies first. Well, and SCA, of course. SAST as static application security testing, DUST as dynamic application security testing, and SCA as software composition analysis, all run in an automated way. MPT as manual penetration testing is a manual method to test applications. They all run on different stages of the application, and they will all find different flaws or vulnerabilities. SAST will run on the code of the application and may find things that are going back into the backend of the application, something like log file injections. DUST will run on live running web applications and will mainly look at the front end of an application. You will be able to identify things like leftover standard credentials or wrongly configured certificates. That is only possible to identify if the application is running. Code analysis will not see how the certificate is set up or which credentials can be used to log into an application. With MPT, you will have the only possibility to identify business logic flaws on your application. No automated scanning technology will, at least right now, be able to identify that. Simple reason for that is there is no artificial intelligence so far. SDA is a bit of the process and only looking at the third-party components of your application. Some DUST technology is able to identify the one or the other library used, but this is more on the static scanning side of the game. If you do automated testing before you do MPT, you could reduce the scope of your MPT. SAST and DUST most probably have identified quite a lot already, and you may want to tell the manual penetration tester to only focus on what they can find, business logic flaws in your application. In addition to reducing the scope of manual penetration tests, obviously, you also reduce the cost of a manual penetration test. One of the reasons why application security testing is perceived as slow and why we need to talk about speed versus risk is clearly the false positive rate in findings. But let's start with the false negatives. They are also an important part of the discussion. You could say you don't know what you don't know, but a solution that is missing a large amount of findings won't help to reduce the risk at all. You're maybe pretty fast in fixing at least what was identified, but the real risk is not really reduced due to the missing findings. Besides, it's quite tough to measure the false positive rate. The false negative rate, of course. False positives, on the other side, will account to the speed part of the game. If there are tons of findings that are not real and actually don't need to be addressed, you will lose a lot of time working on things you don't need to work on. You reduce the risk, but at very low speed. In fact, with a cloud solution like the Veracode solution, we don't need to talk about high false positive rates anymore. You may ask yourself why that is the case. Let me explain the process we have implemented. When a finding is reviewed and you believe this is a false positive, something that should not be flagged and is completely wrong, you can mark it as potential false positive. Every potential false positive will be reviewed by our engineers, and if they agree this is really a false positive, we should not flag this. They will reconfigure our engine, and neither you nor any other customer will ever face this false positive again. Because we have this process at the beginning of Veracode, like 14 years ago, with more than 2,500 customers and more than 3.5 million scans a year, our false positive rate is extremely low. As a result of this process, we learn with every customer, we learn with every application, and we learn with every single scan that is done on our cloud platform. The Veracode false positive rate is at 1.1%, which is very, very low compared to any on-premise vendor, for example. Why? Because you need to do your own false positive reduction with on-premise vendors. You won't tell the on-premise vendor, right? With Veracode, we do that for you. We do the false positive reduction for you. Now, you can already take that off your list. False positive rate is nothing you need to worry about using the Veracode solution. Even if Veracode is a pure cloud platform, we actually don't want developers to log into the platform. We want developers to work where they work anyway. And that's why we integrate into developer tools. Developers don't need to touch the platform on their day-to-day work. We integrate into their IDEs, into repositories, build servers, CI/CD tools, defect tracking, GRC systems, or web application firewalls. Integrations are done via plugins into IDEs, for example, or via the usage of our APIs. What you can see here on the slide are the very prominent names in the market. But with the usage of our APIs, you can integrate literally everywhere. And the best is actually, all these integrations are free of charge. We want you to automate application security testing and integrate as much as possible, because automation is key to success in application security testing. I will show a few statistics over the course of this presentation that will prove how automation is helping to fix fast, reducing risk at speed. For Veracode, application security testing is also a split responsibility between developers and security teams or application owners. As a developer, you don't care about the security requirements. You don't care if that application needs to be PCI compliant, OWASP compliant, or follow any other regulation. Specifically as a developer, you have no idea if CWE 895 that was identified is related to OWASP, PCI, or anything else. For you as a developer, it should be as easy as possible to upload your code, kick off the scan, and review the results. You will see a red shield telling you that is what you need to fix, or see a green shield telling you that is what you don't need to fix. These shields are generated around a policy. The policy is usually set up by security teams or application owners as they know the security requirements of an application. A policy is set up around a technical standard based on the severity or category of the flaw. You can configure how often an application needs to be scanned, and with the remediation grace periods, you can also tell developers how fast they need to fix certain flaw severities. All these rules always in clear text. No one ever needs to learn any proprietary scripting language working with Veracode. As well, the policy only sits on top of the scanning process and is only rating the findings. It is not changing the way we are scanning an application. We always scan for everything, we always display everything, and there is no possibility to hide any of the findings. This is your governance model you put in place on top of the scanning process. This is to manage your risk reduction. Of course, you can tell developers to just fix everything, but application security testing is a lot about prioritization, what to address first and what to look at later on. When prioritizing risk, or let's say findings that pose a risk, you want developers to be fast in fixing, correct? Remember, speed versus risk, that's our topic today. But how do you actually do that? You can either train all your developers before they start working on code, or you set up some sort of e-learning as weekly, monthly, or quarterly campaign. Don't get me wrong, that is something you should always do. Developers can only get better through training. But how do you help them to fix coding defects that have been identified by, for example, static code analysis? Usually, developers are on their own when it comes to find a solution for a coding defect. That can be an easy task, but there can be horribly complex findings, and developers don't know why that is identified and how to fix it, leading to a situation where a flaw is only fixed with delays, accounting to both speed and risk. At Veracode, we want you to fix as fast as possible. That's why we give you or your developers access to our application security consultants. Your developers can schedule 45 minutes web access with them in order to better understand why we flagged the flaw on your code. In addition, the consultant will look at the source code together with the developer within a screen share and give tips on how to remediate that flaw on your very specific piece of code. From our statistics, we can see that developers using this service, they are able to fix 88% more flaws compared to developers not using that service. As well, that is a quite unique service in the market, and therefore using Veracode, you will always have the possibility to fix 88% more compared to using any other vendor. Now, that's a great figure to look at when we talk about speed versus risk, right? I was talking about the fix rate on the previous slide, and we may want to specify what the fix rate is. The fix rate is the proportion of discovered flaws that are successfully closed or remediated. Developers tend to fix those flaws that have the highest severity. Well, for obvious reasons, I guess. Reduce biggest risk first. But if only 56% of all flaws will eventually be fixed, there's still a big risk left open that needs to be addressed. On the previous slide, I already showed you how you can help your developers to be faster. On the next slides, I will talk a bit more about what we can see from our statistics and our SOS reports, and what helps in addition to reduce risk at speed. The SOS reports, our State of Software Security reports, are published once a year with a lot of very useful statistics around things our customers do to reduce risk at speed. All SOS reports can, of course, be downloaded from our webpage. You didn't think about this before, but the scan frequency is an important factor to reduce risk at speed. The only thing I will tell you about this slide is the more you scan, the faster you fix. Well, maybe one more thing. The MTTR that is shown here is the median time to resolution, the time you need to fix 50% of all findings. We will see a bit more around this on the next slides. But let's see first what I talked about in the very beginning on this webinar. How are vulnerabilities found? Let's do the comparison of SAST and DUST. This highlights how much deeper the scanning goes when dynamic scanning is added to the static scanning that is already being done. Don't be confused here. Static will find a lot of other things, but this should highlight what in addition can be found with dynamic analysis. These are complementary methods and should not be considered as subsets of each other or replacements, as they bring their own strengths to application security. Think about annual health checkups. You get blood work done and have a physical because they look at different things, correct? You don't assume you're healthy on the basis of one test. You will wait for all your test results, of course. Focusing on only one type of scan means a whole set of potential flaws may not be discovered, leaving developers in the dark about a significant number of issues across their application. And to come back to our topic today, not reducing the risk. Also, application security testing is not only about finding flaws, at least not for Veracode. We always try to emphasize on fixing flaws as well. You remember I was talking about that previously when we were talking about the consultation calls. Personally, I think that is one of the most important metrics to look at when we talk about application security testing. It really doesn't matter how many flaws can be identified with the different technologies, but what really matters is how many of the identified flaws can be fixed in what amount of time. Because the earlier you fix, the earlier you can deploy or ship a secured application and earn money with it. That is the ultimate goal for every organization, making money out of your applications. So fix rates, for me, is one of the most important metrics to look at when we talk about application security testing. But actually, what we found out in our SOS 11 report is that not all flaws are addressed equally. You also have seen that before with the statistics from our SOS 10 report. Simply put, while many flaws are being addressed promptly, older flaws tend to linger over time. There are several reasons to explain why. The development team may be rationalizing against fixing the flaw because it hasn't caused any problems yet, or thinking that there is no need to spend additional time on a legacy application. Another reason for the lingering flaws could be logistics. The team may not have the capacity to devote the time to fixing flaws, especially if there's more emphasis placed on developing new features rather than reducing security debt. Okay, getting into the main topic of the SOS 11 report here, nature versus nurture. What is affecting fixing flaws in a positive or negative way? One thing that is clear is that one of the biggest obstacles for developers is a ponderous application with a dodgy security history. Large applications with high flaw density slow down the remediation rate of flaws by about 2 months each. If you're building up a new application, keep an eye on the size and complexity of the application. Larger applications are clearly also associated with slower, less remediation times. As development progresses, stay on top of the flaws as they are discovered. Don't let the security debt pile up. Secondly, if you have inherited a large application that is carrying quite a bit of debt in the security flaws, the data suggests that teams should consider re-architecting their applications or retire legacy applications in favor of streamlined code. Refactoring applications to use microservices may help clean up some of the issues, especially if the same flaw is present in different parts of the application. But there's also hope, as there are several things that a developer can have more direct control over. And those are the things we generally associate with good development practices and faster flaw remediation. Scanning frequently and using dynamic scanning in addition to static scanning can each reduce the half-life by as much as a month. Dynamic scanning may improve fix rates because it highlights to developers that the vulnerability does in fact have real-world risk. What we found for applications that have integrated security testing with the API, that is building security analysis directly into the development pipeline, is quite interesting. Not only does the integration make scanning more automated and easier, but it also negates the need for developers to remember to manually run the security scanner. More importantly, we found a significant change in the remediation rates for applications that integrate scanning into the pipeline. Even though we look at each of the factors that affect fix rates individually, we know that very few of these things exist in isolation in real-world software development. So we look at the factors as a group and ask the question, nature or nurture? In order to determine whether the greatest impact comes from things the developer can't change or decisions under the developer's control, we begin with two hypothetical applications. The first comes from an ideal environment, which is identified as a small organization with an application that is small in size and has low flaw density and is relatively new in terms of application age. The second has less ideal properties, which is a large application built long ago at a large organization with high flaw density. We also have two hypothetical teams working on these applications. One team follows best practices, including frequent regular scanning using a variety of scanning types and including software composition analysis. The other team uses only static scanning infrequently and at irregular intervals. With the setup of the previous slide, let's have a look at what affects fix rates and reducing risk at speed. The slowest line here represents an application challenged with negative attributes and negative behaviors of the team. They tend to close quite a bit slower and less flaws than anyone else. The quickest line here, representing the best case, positive attributes of the application with proactive development, with a proactive development team with positive behaviors. In reality, most applications will fall between those two with a mix of attributes and actions. What is interesting here is the impact good practices can make. In our idealized good application, having good practices mean 50% of flaws are closed in just under 2 weeks, while bad practices on the same application can mean it will take almost twice that time to close 50% of the flaws. The differences are even more stark when we look at bad applications. A team with bad practices working on a less than ideal application may take nearly a year to close 50% of the flaws. A team with good practices on the same unideal application would cut that time to about 6 months. It makes sense that flaws are fixed quicker in applications that are being developed under ideal conditions. But the pattern shows that developers can also influence the outcome by changing their specific behaviors. So, simply put, setting up an application security testing program and helping all stakeholders to understand what they need to really do will also help you to reduce risk at speed. We now talked a lot about first-party code so far, but your applications are not only made of first-party code. You most probably use a lot of third-party dependencies, libraries, and frameworks. They also obviously pose a risk to your applications that you would like to reduce at speed. We have very recently published our SOS report open source edition, where we talk about open source only. This will be the source of the next topic here. As Veracode, we can see that 80% or even more of an application today is not first-party code anymore. Of course, it depends a bit on the language, but open source components are very widely used in today's applications. We also found out that those libraries are not updated, or at least are not updated frequently, leaving your application at risk. There's a lot Veracode can help with in regards to third-party components, and we will have a look at that on the next slides. The SOS open source edition also found a very concerning fact in regards to our topic, speed versus risk. To update 50% of libraries with vulnerabilities, developers need more than a year. That is leaving your application at high risk, besides not fixing at speed, obviously. What could be the reason for such a long fix time? Well, we can only speculate, right? But I guess one of the biggest reasons is that developers just don't know there is a known vulnerability within the version they use. And even that information is available, they may don't know if the vulnerability affects their application or not. Therefore, one of the major things you need to do to reduce the open source risk at speed is telling developers about it and scan your third-party components. So what can you do about that? Or better to say, how can we help you to address this risk with speed? First of all, introduce open source scanning, but also provide meaningful results to developers to help fix these findings at speed. At Veracode, we, for example, monitor open source repositories. And whenever there is an official commit into this repository, we verify in an automated way if this commit was done to add a new feature or if it was done to fix a security defect. If it was due to fixing a security defect, that data will end up on our database right away. Compared to the NVD database, this is the time when it will be announced to the NVD guys, and they need 3 to 6 months before you will get a CVE ID, leaving your application vulnerable for this time as you cannot see it on the NVD database. We also need to think about what we call silent fixes. If a security defect was fixed but never announced to the NVD guys, well, you will never have it on the NVD database. With Veracode monitoring the commits, you will also have it on our database. With Veracode, we have that data first, 3 to 6 months faster, and second, we have a lot more data compared to whatever will be on the NVD database. One thing that is very important for developers to know, as well to better prioritize the risk, would be if the vulnerability is affecting your first-party code or not. If the function that is causing the vulnerability is not actively used on your first-party code, your application is not affected, and you can still very safely deploy or ship your application. The other way around, if the function that is causing the vulnerability is actively used on your first-party code, that most probably makes your application exploitable and should be fixed as soon as possible. Of course, you should always exchange all libraries with known vulnerabilities, but regarding our topic today, you should fix first what poses the biggest risk. Another reason why developers don't update libraries is most probably that sometimes it's not a very easy task, and you need to update a full chain of transitive libraries. With Vercode's dependency graph, developers can easily evaluate the time they may need to spend in updating deep down transitive dependencies. Last but not least, developers should see right away if there is a newer version of a vulnerable library, so they can start fixing that right away. In addition, they should also know if there is a newer version, even if there is no vulnerability detected right now. All right, that was a lot of content in a very short amount of time. We have talked about all these topics here and how you can reduce the risk on your applications at speed. Well, maybe better to say how Veracode can help you to shift your application security testing approach from just finding flaws and vulnerabilities to really fixing them at speed. The main conclusion for today is that Veracode has your back when it comes to application security testing. In a single Veracode platform Veracode combines all the different technologies like SAST, static code analysis, integrated into the developer's IDE to scan single files while they work on these files, fully integrated into your CI/CD pipeline to scan at the commit stage. SCA, software composition analysis, verifying third-party components of your applications. Dynamic analysis to test a live running web application. Maybe one little announcement here, we will very shortly have dynamic API testing as well. MPT, manual penetration testing. Yes, we also do manual penetration testing that is often a strong requirement for financial organizations to comply with regulations. All that is bundled with a single cloud platform and enables you to see the policy rating we have talked about earlier today for each application and all the testing methods with a single click. We have combined this with our industry-unique services to provide guidance to developers how to fix faster with our application security consultants, or with our security program managers helping you to operate a full application security testing program. Last but not least, we have a full e-learn platform integrated into our application security testing platform. Now, decide on your own. What do you think? Do you still need to choose between speed or risk? As a last conclusion, we can safely say, Veracode with static analysis, dynamic analysis, software composition analysis, manual penetration testing, and a single platform to build a governance model is perfectly suited to help you reduce the risk at speed. Thank you for your time today, and let's see if we have any further questions. Thanks for attending, stay safe, and hope to see you soon in person again.